Hello, today we're doing lesson 5.6 and 5.7 part 2. This time we're working backwards. We're going to be given the zeros of a polynomial function and now we need to write a function. When the zeros given are all reals, it makes it pretty easy. So think about it like this. What if you had a polynomial already factored and you got these as the answers, 2, -4, 5. What are those factors that you got? The opposite, right? You got x minus 2, x plus 4, and x minus 5. Right? Because if we were to set each of these parentheses equal to 0, we would get a positive 2, a -4, and a 5. So this is pretty easy. So how do we work backwards? We just multiply it all out. And we've already done polynomial multiplication. So in this case, I'm going to go ahead and FOIL that. And then I'm going to take my new polynomial and multiply it by x minus 5. Okay, so I get x squared. I get positive 4x minus 2x. That would be positive 2x. And then minus 8. That's what I get when I FOIL it all out. I'm combining the middle terms in my head. I'm not writing that step down. And then I'm going to multiply it by x minus 5. So I'm going to make sure I multiply x squared by both of these. So that gives me x cubed minus 5x squared. Now I'm going to multiply 2x by both of these. So that gives me 2x squared minus 10x. And then I'm going to multiply -8 by both of these. That gives me -8x and positive 40. Then I'm going to go ahead and add up my like terms. X cubed minus 3x squared minus 18x plus 40. Okay, I had 3 answers and I have a polynomial of degree 3. I'm done. Not bad, right? So I would like you to go ahead and pause the video and try this one on your own. I'll give you a little hint to get started. The factors that you need to multiply out are the opposite of what we see. X plus 3, x minus 1, and x minus 6. Okay, go ahead and pause the video and give that a try. Welcome back. Now we need to talk about the complex conjugates theorem. If f is a polynomial function with real coefficients and a plus bi is an imaginary zero of the function, then a minus bi is also a zero. So if we have a complex number, we know that the conjugate of that complex number is also going to be a zero, whether it's written or not. Same thing as our rational conjugates theorem. Suppose f is a polynomial function with rational coefficients and a and b are rational numbers such that the square root of b is irrational. If a plus square root of b is a zero, then a minus square root of b is also a zero. We're going to need to know this when we go ahead and try the next problem. The next one gets a little bit more complicated. Now, we can do it the same way I did above. So let's talk about that. The directions say write a polynomial function of least degree that has rational coefficients and a lead coefficient of 1 and the given zeros. Okay, so here's what happens. These are the solutions you were to get if we were to solve. Now, based on the theorem I just talked about, if this complex number is a solution, so is this complex number. Okay, so we have 3 answers, which means we're going to have a degree of 3. Now, what would the factors be? It would be x minus 2. It would be x minus this whole complex number. And it would be x minus this complex number. I'll show you this one. So we can go ahead and distribute, but look what we're going to have. We're going to have to multiply a binomial times a trinomial times a trinomial. That's really big and messy, and you can do it and you will get the right answer, okay? But there's a shortcut. So let's go ahead and talk about the shortcut. Shortcut is step 1. We're going to take our real solution and we're going to write it as a factor. So step 1 is to write x minus 2. Now I'm going to come back to this. When you do this, go ahead and start by writing x squared. Okay, we're going to come back to this. So we're not going to do anything with this now. We'll come back to this one later. Step 2 is we're going to take the conjugates and we're going to add them. So we're going to add -2 minus 5i plus -2 minus 5i. When you do that, you get -4 minus, oh, excuse me, that should be a plus. That's gone. 0. So you get -4. Now, what you're going to do is you're going to take -4, you're going to change the sign, so write change sign, and you're going to write that as your x term. So it's going to be positive 4x. Okay, step 3. Now you're going to multiply the conjugate. So I'm going to multiply -2 minus 5i and negative 2 plus 5i. Now remember, when you do this, the middle terms cancel out. So I'm going to get positive 4, and then I'm going to get negative 25i squared. Remember, I squared is negative 1, so this becomes a plus 25. So 4 plus 25 is 29. You're going to write that, no sign change, as your constant. So now all you need to multiply is our first factor by this polynomial. So it's a little bit messy, but not as bad. So if we go ahead and multiply this all out, I'll go ahead and write the work over here. We're going to have x minus 2 times x squared plus 4x plus 29. So when we do that, we go ahead and we get x cubed plus 4x squared plus 29x minus 2x squared minus 8x minus 58. Go ahead and add up our like terms. We get x cubed plus 2x squared plus 21x minus 58. Look, I had 3 solutions, and I have a polynomial with degree 3. Now let's go ahead and try that again, this time with square roots. Okay, so this is what I'm given, 4 and square root of 5. Okay, I have a square root, so I know I also have the conjugate. I have the negative square root of 5. Step 1, we're going to go ahead and write our factor with our real number. That would be x minus 4, and while we do that, we're going to write x squared. Now we're going to go ahead and add the conjugates. Square root of 5 plus negative square root of 5 is 0. We don't need to change the sign on a 0, but if you want to go ahead and do that so you remember to change the sign, go ahead. Then we're going to multiply the conjugates. Square root of 5 times negative square root of 5 is negative 5, and we're going to go ahead and write that down. Now this one is a lot easier because now all I need to multiply is x minus 4 and x squared minus 5 because we have no middle term. So we get x cubed minus 4x squared minus 5x plus 20. Not so bad, right? Shortcut's a little bit better than multiplying all of that out. So let's go ahead and take a look at the U tried. You have a real number of 8. You have 2 plus I, and we have the conjugate of that, which is 2 minus I. So go ahead, try this shortcut, try the problem on your own, and we'll talk about it tomorrow in class. If you have any questions, comments, or concerns, go ahead and write that at the bottom of the video, and we'll also address that in class.